Okay. Let's go. Where do I leave off? Check solutions. I'll just check all the solutions again. So negative 49, 3, 0, negative 90. Okay, well, that's wrong. Alright, what happened here? This one's right, this one's not. I wonder if I, like, forgot to delete this or something. Okay, E. Okay. Oh, wait, what? I'm so confused how I got this answer. Okay, so this is... I forgot to distribute the negative 2 at the very beginning. That's why I'm getting positive 16 instead of negative 32. I don't know where this answer came from though. So I'll just... negative 32x squared. Change this to... okay, that's right. Then F. Or, yeah, F. This is all messed up. I'll just redo this one. I don't want to go checking for like a mistake because I did this yesterday. So f of x plus h equals 3 minus 5 x plus h minus 2 x plus h squared. Okay. So 3 minus 5, 7. Wait, 7. Yeah, okay. X plus h minus 2. Okay, I can do it from here. So I'll just write this in red. X squared plus xh plus xh. I'll just write this 2xh plus h squared. Distribute the negative 2 x squared minus 4xh minus 2h squared. And this 3 minus 5x minus 5h. 3 minus 5x minus 5h minus 2x squared minus 4xh minus 2h squared. Okay. I don't even know what I did yesterday. It's way off. Okay. So that's number 1. Two. G of t equals t 2t plus 6. A. G of 0 equals 0 2 0 plus 6, which is just 0 anyway, so it doesn't really matter. B. over -3. -3 over 2, -3 plus 6. 0 in the denominator. Undefined. C. H of Z. Wait. Okay, I'm doing C, not 3. G of 10 equals to -3. No. Put the parentheses so I remember. Wait. Yeah, this is negative. 10 to 10 plus 6. 10, 20 plus 6. 10 over 26. 5 over 13 is the answer. D. For D, we got G of x squared equals x squared over 2x squared plus 6. X squared over 2x squared plus 6. And that is the answer. E. G of t plus h equals t plus h over 2t plus h plus 6 t plus h over 2t plus 2h. T's and the pluses look pretty similar. Plus 6. And that's the answer. Can I factor anything out? I could factor out at 2, but it's not going to do anything. So we're gonna go with that. F. Can I factor anything out here? No. Okay. So F G of t squared minus 3t plus 1, put a whole quadratic in here, equals t squared minus 3t plus 1 over 2t squared minus 3t plus 1 plus 6 t squared minus 3t plus 1 over 2t squared minus 6t plus 2 plus 6 t squared minus 3t plus 1 over 2t squared minus 6t plus 8. Can't factor anything out, so could I hold on. I'll go with this for now. There might be like a factored answer like this, but we'll see. Okay, solutions. So A is 0, B is undefined or does not exist, C is 5 over 13, D is x squared over 2x plus 6. E is t plus h over 2t plus 2h plus 6. F is t squared minus 3t plus 1 over 2t squared minus 6t plus 8. Okay. Whoops. Ignore that. Alright, calculus 1, 3. Calculus 1, 3. 3 pages in, haven't got to any calculus yet. Can you believe it? Alright. I got rid of that. Alright, next one. 3. H of z equals square root of 1 minus z squared. A h of 0 equals 1 minus 0 squared, which is 1. Square root of 1, which is 1. B is, what is it? H of negative half equals square root of 1 minus negative half squared, which is half squared, square root of half, I mean. Which is 1 square root of 1 over square root of 2, which is 1 over square root of 2. Rewrite that, square root of 2 over 2. C. H of half, it's going to be the exact same thing. I'm not even going to do the work. Okay. D. H of 9z equals square root of 1 minus 9z squared. You know what? I did this wrong. B. When I squared it, I didn't actually. I just made it positive. I didn't square it. So it would be 1/4 minus 1, which is should be 3/4. Yeah, 3/4. Square root of 3/4. Square root of 3 over square root of 4. Square root of 3 over 2. Then C would be the same thing then, still. And then D, H of 9z equals square root of 1 minus 9z squared, which is 81z squared. 1 minus 81z squared, which I think that's it. E is H of z squared minus 2z equals 1 minus z squared minus 2z squared, which is 1 minus 4 minus 2z squared, 4 minus 2z, 4 minus 2z. Whoa. Okay. So 16 minus 8z minus 8z. Let's rewrite this minus 16z plus 4z squared. So got negative 15 minus 16z plus 4z squared. I'm going to rewrite that in standard form. 4z squared minus 16z minus 15. F h z plus k equals square root of 1 minus z plus k squared. 1 minus z plus k times z plus k square root of 1 minus z squared plus 2z k plus k squared. Rewrite that. Z squared negative z squared plus k squared plus 2zk plus 1. Is that it? That's it? Yeah. Okay, so this is 1. B is square root of 3 over 2. C is square root of 3 over 2. D is square root of 1 minus 81z squared. E is square root of 1 minus 4z squared plus 4z cubed minus z. Okay, how did I mess that up? Wait, did I not put a z squared? I thought this was a 2. Are you kidding me? I put the lines in there for a reason too. Oh man. I literally put lines in my z's just because of that, and I still messed it up. Alright, 1 minus z squared minus 2z times z squared minus 2z. So that's z to the power of 4 minus 2z cubed minus 2z cubed, so minus 4z cubed, we'll say. And then plus 4z squared. I'll put the positive 1. Well, no, I gotta, wait. 1 minus. Okay, so this comes in negative z to the power of 4. So negative z to the power of 4 minus 4z cubed plus 4z squared plus 1. That's the answer. Okay, they wrote it different, but this is a plus 4z cubed. Okay, you know what? I think messed me up. Hold on. So I'll move this over. How can I move it over? There, okay. So negative, what the heck? I'll distribute the negative maybe? 1 minus z power 4 plus 4z cubed minus 4z squared. 1 minus, okay, how'd they even write this? It's so weird. 1 minus 4z squared plus 4z cubed minus z to the power 4. Okay, I'm not gonna rewrite the whole thing, but yeah. Stupid mistake at the beginning. I'll move this up then. And then f is 1 minus z squared minus k squared. Okay, I think I did the same thing without distributing the negative. So I'll just fix that. Should be good. So square root of 1 minus z squared minus 2zk minus k squared. So 1's positive, z squared's negative. Okay, same order. Minus 2zk minus k squared. Okay, we're good. So that's 3. Four. R of x equals square root of 3 plus x minus 4 over x plus 1. Okay, so A is R of 0 equals 3 plus 0 minus 4 over 0 plus 1. So this is square root of 3 minus 4. B is R of 6 equals square root of 3 plus 6 minus 4 over 6 plus 1. This is 3 minus 4 over 7. C is R of negative 9 equals square root of 3 plus negative 9 minus 4 negative 9 plus 1 square root of 3 plus, yes, what is it, negative 6 what are you doing as a negative in the square root? Gotta look it up. What's to do if there is a negative in the square root?
In this video, let's learn how to simplify. 4 is 2 times 2 equals 4. So if you take the square root of negative 4, you have negative 2 times negative 2, but that also equals 4. 4, 2.
Do I just leave it in there though? Here, how to simplify the square root of a negative number.
Take the square root of negative in our real number. However, so what I'm going to do is I'm going to rewrite this as 36 times negative 1. Therefore, by using my rules of roots, I can now rewrite this into the negative times the square root of 36 times the square root of negative 1. Where now I can rewrite the square root of negative 1 just as I. And now I just need to focus on what is the square root of 36, and I'm going to multiply that value times a negative. Or you could think of that as like a negative 1 times square root of 36. So what I noticed is for the square root final. So
Okay. So I can rewrite this as square root of 6i. Maybe. Minus 4 over negative 8, which would be plus half. I think it's square root of 6i plus half. D R x plus 1 equals square root of, whoops, square root of 3 plus x plus 1 minus 4 over x plus 1 plus 1. Okay, so square root of 3 plus, let's say 4 plus x minus 4 over x plus 2 that's it. E R of x power of 4 minus 3 equals square root of 3 plus x power of 4 minus 3 minus 4 x power of 4 minus 3 plus 1 square root of 3, there's a negative 3, so it's just x square root of x power of 4 minus 4 over x to the power of 4 minus 2. This can be rewritten over here as just x squared, I think. Yeah. Minus 4 over x to the power of 4 minus 2. I think that's the answer. F. R of 1 over x minus 1 equals square root of 3 plus 1 over x minus 1 minus 4 over 1 over x minus 1 plus 1. So 2 plus 1 over x minus 4 over 1 over x square root of 2 plus 1 over x minus 4x, I think. Yeah. Okay. Let's check them. So r of 0 is square root of 3 minus 4. R of 6 is, oh, I can rewrite this. I'm goofy. I gotta get rid of the box, bro. So what's the what's it called? Most common denominator. Jeez, dude. Okay. Well, it's over 1, so oh man, I'm tired. Okay. So it would be 21 over 7 minus 4 over 7 17 over 7. Yeah, okay. C. Oh, what happened here? There's no I. In this class, we only deal with functions that give real values as answers. Therefore, we have the square root of a negative number. In the first term, this function is not defined. Oh, okay. Wait. Oh, so my answer, I don't think my answer is even wrong. I think in calculus, wait, are there no imaginary numbers in calculus? Imaginary numbers become particularly useful in advanced calculus, or calculus 1. Imaginary numbers become partially useful in advanced calculus. Sounds like imaginary numbers just aren't a thing in calculus. Yes, imaginary / complex numbers are used in calculus. When differentiating, integrating complex number, I works like any other constant would. Okay, I mean, I guess he just means in this class, kids class. But I'll delete this. So the best form would be square root of -6 minus 4 over -8. And that's how he leaves it. So what do I say? Undefined. Note that the fact that the second term is perfectly acceptable has no bearing on the fact that the function will not be defined here. If any portion of the function is not defined upon evaluation, then the whole function is not defined at that point. So also note that if we allow complex numbers, this function will be defined. If we allow complex numbers, this function will be defined. Okay. R of x plus 1. 4 plus square root of 4 plus x minus 4 over x plus 2. Okay. R of x to the power of 4 minus 3. X squared minus 4 over x to the power of 4 minus 2. F r of 1 over x minus 1. Square root of 2 plus 1 over x minus 4x. Okay. Number 5, let's go. No, like, just having one problem at a time. These are the assignment problems. The difference quotient of a function f of x is defined to be. What's the difference quotient?
In this lesson, we're going to focus on finding the difference quotient of a function. So let's say we have a function f of x and it's equal to 7x. What is the difference quotient of that function. Now, the difference quotient is represented by this formula. It's f of x plus h minus f of x over h. Now, we already have f of x is 7x. What do you think f of x plus h represents? Well, all you got to do is replace x with x plus h. So it's 7 times x plus h. So this expression becomes 7 x plus h, and then minus f of x, which is already just 7x, divided by h. Now, we need to distribute 7 to x plus h. So 7 times x, that's going to be 7x. And then 7 times h, so we're going to have plus 7h, and then minus the 7x that was already there. So 7x minus 7x, those two will cancel. And so we're left behind with 7h divided by h. And so h divided by h is 1, so they cancel, leaving behind 7. And so that's the answer. The difference quotient of 7x is 7. Try this example.
Okay, but what is
Let's
it?
say that f of x is 5x plus 4. Go ahead and find the difference quotient of
Yeah, and it's not just like a light class of guys too. It's like grand functions guys. And the girls are all good. They're all like nice, sweet, quiet girls, you know. So I think we do next time is like put them in little groups.
Mark Lossier, can you please report to Dr. Richardson's office? Mark Lossier, please report to Dr. Richardson's office.
All right. So we're going to do the difference quotient. We're going to simplify the difference quotient. So rather than making this very, very confusing, I'm going to try to make this as simplistic as possible. We see this crazy stuff right here. F of x plus h minus f of x all over h. It's just like, why am I doing this? Why do I have to do this? Let's try to simplify this as much as possible. First of all, let's just try to remember, if I was going to find f of 1, right? I would plug 1 in for all my x values, correct? If I wanted to evaluate this, right? So let's just try to think of this way. They're saying, well, rather than evaluating for f of 1, they want me to evaluate for f of x plus 8.
Man, what a great way of explaining that, actually. Good job, Brian.
So I'm going to do the same thing. I'm going to multiply x plus h squared minus 2 times x plus h. Do you follow me? See what I did? All right. So let's go ahead and figure what this is going to be. All right. Remember x plus h squared. I'll break this down quick. X plus h. X times x is x squared. X times h is xh. X times h is xh.
Mr. Cutter, can you
H
please
times
call
h
Miss
is
Klein
h
at
squared.
1038? Mr. Cutter, please call Miss Klein at 1038.
All right. So
I don't
back to
get-
that binomial.
I don't get how these cube things are easier than just like foiling. Is that what he's? Yeah, I don't understand that.
Or when I expand that binomial, I now get 4 times x squared plus 2xh plus.
I don't want to
h
skip because
squared.
I'm afraid he's going to just explain it in the middle of this. If
So
not, I'll probably go to
minus-
Wikipedia.
Now let's just do it. It's 2x plus h. Now what I have is, I can now do my distributive property, right? This is like a lot of steps. But the steps hopefully you can follow. There's nothing new we're doing. I know it's like crazy, but we're just following the steps. So distributive property. 4 times x squared is 4x squared plus 8xh plus 4h squared minus 2x minus 2h. Pretty big, isn't it? It's a lot. But do you see what I have there? Does that make sense? So that is this. I just did that, right? You see what I did? I just did one part of it. So I just said, take this, what this was, this huge thing, and then it said subtract f of x. Well, what was my f of x? That's 4x squared minus 2x. So I take 4x squared, I'm just going to rewrite it all over again. xh plus 4h squared minus 2x minus 2h minus f of x, which is 4x squared
Kelly, click, please call the main office. Just click, please call the main
Jeez, the
office.
third time on the speaker.
So you do negative 4x, of course, right there in the video. So you negative 4x minus 4x squared minus 2x. Well, that can be, I can distribute that negative sign and make this a negative 4x plus 2x squared. All right? See where I'm at? Now that's that. Okay? So now I got that done. Well, what we're going to do, and what you can see is, those are opposites, right? Those cancel out. Got me? These are opposites. These cancel out. Right? So when I finish up this top here, I'm only left with a 4h squared plus 8xh minus 2h. Follow. Then we got to put it on range. Right? Well, now what we notice is I can now simplify. I can divide this h into all of these. So what I can do is I can cancel these h's, cancels out, and cancels out. Right? Right? So therefore, my final.
If I was Brian, I would have shown how to factor that out, but maybe he wasn't trying to like confuse them too hard. This might be like a algebra class or something. Because at the beginning of the video, he's like afraid this would be like too complicated.
Is 4h plus
But I actually think it'd be easier to show like factoring that out
8x
than just like crossing out like the h's.
and what is 9? 0. That's what I want to do. What?
Oh yeah, Mario explains what it is. Nice.
So what is the difference quotient? Well, you can see difference means subtracting, quotient means dividing, and this is the formula here. It's f of x plus h minus f of x all over h. And this is starting to get into some calculus. This video is intending more for pre-calculus students, but basically what you have here is here's x, and here's the point f of x on this curved region right here. If you go a little distance to the right, we're going to call that distance h. That puts you over here at x plus h. And if you go up to the curve, that y-coordinate is f of x plus h. Now, if we use our slope formula is y2, okay, so y2 minus y1 over x2 minus x1. Here you can see the x's are going to cancel one another out. That's where this difference quotient comes from over here. And then what happens is if you take the limit, okay, as h approaches 0, meaning as this distance between this point and this point gets smaller and smaller, this point moves along the curve. What happens is if you take the limit, okay, as h approaches 0, meaning as this distance between this point and this point gets smaller and smaller, this point moves along the curve until these points, they coincide with one another. And so what happens is, instead of getting this average rate of change, this secant line right here, you're actually getting the instantaneous rate of change, okay, which is the slope at that point here. So we're using the slope formula, but we're using limits to bring these points closer together until they coincide, and then we get the instantaneous rate of change. That's the slope at this point here.
He's throwing around a lot of words that don't really mean anything to me.
But what we're going to talk about here is just how to work with finding the difference quotient.
Okay, I don't need to watch that part. I didn't understand how it's just the distance, or the slope, or whatever you want to call it, between these two. Because this is the slope, right? You said same, like
So
slope
y
formula.
is h. Now, if we use our slope formula,
Yeah. Okay. It was easy to find out how to calculate a difference quotient. This is the first resource I found explaining what a difference quotient actually is. True. So they actually just throw this in and expect you to just... I don't even know. They just want you to solve for it. They don't want you to actually understand it. Or like it's not important to the class. That's weird. Because I don't think this was in the notes for this. Yeah, look. This wasn't in the notes. He just puts this in the practice problems and then says to solve for it. And this is actually in my review packet too for like after school. So that's kind of odd. It is kind of complicated. Like, what was that word he used?
over x2 minus x1. Here you can see the x's are going to cancel one another out. That's where this difference quotient comes from over here. And then what happens is if you take the limit, okay, as h approaches 0, meaning as this distance between this point and this point gets smaller and smaller, this point moves along the curve until these points, they coincide with one another. And so what happens is, instead of getting this average rate of change, the secant line right here, you're actually getting the instantaneous rate of change.
Yeah, like rate of change, instantaneous, secant line. Like maybe that's why they don't explain it, because I'm not understanding most of that. Anyway, I can do the problems. I'm not too worried about not understanding that for now. I'm sure it'll come back eventually. Of x equals 4x minus 9. I'll just write the formula down here. Okay. F of x plus h equals 4x plus h minus 9. 4x plus 4h minus 9. That's what it equals. 4x plus 4h minus 9 minus 4x minus 9 over h. 4x plus 4h minus... No, 4x's cancel out. So it's just 4h minus 18. Yeah, okay. Over h, I think. 4h over h minus 18 over h. 4 minus 18 over h. Which way is better to write this? Either, I like this one better at the top, but I'll write it at the bottom. It's a little more simplified, I guess. 1 less h. all steps. No, I did it wrong. Did the 9s cancel out? Oh, okay. Because I saw the 2 negative 9s. I was like, these don't cancel out, really? I should have checked. Let's see. Okay, I see. So f of x is 4x minus 9. You gotta distribute the negative. That's my problem. 4x plus 4h minus 9 minus 4x plus 9. 9's cancel out. 4x's cancel out. 4h over h. 4. Alright. G of x equals 6 minus x squared. So I'm guessing you just change the f to a g in that formula. Here, I'll copy it down. So g of x plus h equals 6 minus x plus h squared. X plus h, x plus h, x squared plus xh plus 2xh plus h squared. 6 minus x, well, I gotta distribute the negative. X squared plus 2xh plus h squared. 6 minus x squared minus 2xh minus h squared. And that's it. So I plug that in. 6 minus x squared minus 2xh minus h squared minus 6 minus x squared all over h. 6 minus x squared minus 2xh minus h squared minus 6 plus x squared all over h. These cancel out. These cancel out. Negative 2xh minus h squared over h. Factor out an h. Negative 2x minus h over h. H's cancel out. Negative 2x minus h. What is this? 6? Yeah. Negative 2x minus h. Okay. Seven. F of t equals 2t squared minus 3t plus 9. Copy that down. Did I? Wait. Copy this whole thing? Are you kidding? Oh wait, I forgot how layers work in this. Can I merge the layers? Merge all of them. Copy this down and merge it. So f of, we'll make these t's so it's easier. F of t plus h equals 2t plus h squared minus 3 t plus h plus 9. T, oh, do this in red. T plus h, t plus h, t squared plus th plus 2th plus h squared. So this ends up being 2 times t squared plus 2th plus h squared minus 3t plus 3h plus 9, which is 2t squared plus 4th plus 2h squared plus 3t plus 3h plus 9. Wow, none of these cancel out, or I mean, combine or anything. 2t squared plus 2h squared plus 4th minus 3t plus 3h plus 9. Okay. That's just t plus, yeah, it's just t plus h. F of t plus h. So I'm not writing all that out again, so I'm just gonna plug it in now. So negative, what's f of t? 2t squared minus 3t plus 9. So 2t squared plus 2h squared plus 4th type. I didn't put silver h. Plus 4th minus 3t plus 3h plus 9 minus 2t squared plus 3t minus 9. So the 9's cancel out. The 3t's cancel out. The 2t squareds cancel out. So we're left with, oh, put over h. 2h squared plus 4th plus 3h. Is it th, right? That doesn't seem right. Where'd I get that from? From this original factor. T squared plus th plus th. 2th, okay. Over h. Okay, it's gonna factor the h out. So h, 2h plus 4t plus 3 over h, cancel out, 2h plus 4t plus 3. It seems right. T plus 2h plus minus 3. Oh, okay, I do. So that comes from the positive 3h. That's up here. Okay, this came in along this step. Wait, no. Minus 3t minus 3h. One sign throws off the whole thing. Unfortunate. How many more negative 3s I gotta change? Negative 3 H's. Okay, finally. Each y of z equals one over z plus 2. Copy down the difference quotient. Did I just move it down? Yeah. I mean, I guess that works actually. I'll change it to z this time. Y of z plus h equals 1 over z plus h plus 2. 1 over z plus h plus 2. 1 over z plus h plus 2 minus z plus h all over h. 1 over 2 plus h plus 2 minus 2 minus h. Okay. So I'm thinking I could do negative 2 minus h times 2 plus h plus 2 negative 4 minus 2h minus 4 minus 2h negative 4 minus 2h plus, no, minus 4 minus 2h minus h squared minus 2h. Okay. So minus 6h is h squared minus 8 over two plus h plus 2 put 1 up there over h over 1. 1 minus h squared minus 6h plus 8 over 2h plus h squared plus 2h negative h squared minus 6h minus 7 over h squared plus 4h. Seems so wrong. What is this, 8? 8. Okay, what did I do? So found y of z plus h. 1 over z plus h plus 2 minus 1 over z plus 2. Wait a minute. Why did I put minus 2 plus h? Are you kidding me? Like, where'd this even come from? That's so stupid. Where did I even get that from? So it'd be 1 over z plus h plus 2 minus 1 over z plus 2 over h. So if I multiply 1 over z plus h plus 2 minus 1 over z plus 2 I have an idea. So z plus h plus 2 z plus h plus 2 1 over z plus h plus 2. No, that's not gonna work. Oh. What do they do? Okay. Z plus 2 over z plus 2 times 1 over z plus h plus 2 minus 1 over z plus 2 times z plus h plus 2 over z plus h plus 2 z plus 2 over z plus 2 z plus h plus 2 minus z plus h plus 2 over z plus 2 times z plus h plus 2 z plus 2 minus z minus h minus 2, get rid of the parentheses, over z plus 2 z plus h plus 2. Oh, that's it. Okay. So at the top we got these cancel out, the z's, the 2's cancel out, left with just negative h over z squared. Okay, this is a big one. Plus zh plus z plus 2z plus 2z, which is plus 4z plus 2h plus 4. So negative h over z squared plus 4z, no, zh plus 4z plus 2h plus 4. So the exact same thing I wrote. No. Yes. Okay. Still not the, wait. I can't factor out an h. I'll just go through what they did again. So they have negative h over z plus h plus 2 over times z plus 2. Note that when dealing with difference quotients, it will almost always be advisable to combine rational expressions into a single term in preparation of the next step. Why? What? Wait a minute. In this step we rewrote the difference quotient a little to make the numerator a little easier to deal with. Seriously? Okay. So let me get rid of I just want foil. Wait, whoops. So he rewrites this so that it's 1 over h times the numerator. Wait, so everything that I did here was without the h. Oh, okay. So there's still an h on the denominator that I haven't wrote. I understand now. So it would make this easier with 1 over h. So negative h over, okay. You just write h z plus 2. So I see why it's easier to leave the, what are these called? The rational expressions to a single term. So negative h over h, that's negative 1. So got negative 1 over z plus 2 z plus h plus 2. Negative 1 over z squared plus zh plus 2z, which is 4z, plus 2h plus 2z, which is 6z. Wait, why'd I have 2z again? Be plus 4. Oh, they just left it. And this, all that we're doing here is using the fact that, yeah, kinda. So they didn't even FOIL at the end. Fair enough. It was 8, right? Okay, we're on 9. So a of t equals 2t over 3 minus t, a t plus h equals 2t plus h over 3 minus t plus h. 2t plus 2h over 3 minus t minus h, which is the answer. So then we do, what's that? Formula. Drag this down again without copying it. Wait, this isn't a formula. It's an answer. Not even an answer, but it's a random step. Where'd it go? Here. Okay. So 2t plus 2h. Whoa, what is that? It's 2h over 3 minus t minus h. Minus 2t over 3 minus t. So times 3 minus t over 3 minus t times 3 minus t minus h over 3 minus t minus h. Three minus t, 2t plus 2h, 3 minus t, 3 minus t minus h, minus 2t, 3 minus t minus h, 3 minus t, 3 minus t minus h, six t plus 6h. Wait, what am I doing? No. I'm just going mindless. Okay. So 3 minus t, 2t plus 2h minus 2t, 3 minus t minus h. 3 minus t, 2t plus 2h minus 2 do I not yet. Minus 2t, 3 minus t minus h. 3 minus t, 3 minus t minus h. These cancel out. These cancel out. 2t plus 2h minus 2t. 2t's cancel out. 2h, I believe. This is 9. Wait, is this 9? It is. Oh wait, you can't cancel out. There's a negative. You're subtracting 2 terms, so you can't do that. Okay. 6t plus 6h minus 2t squared minus 2ht. No, th. That's what I did last time. Minus 2t. Oh yeah, stop. Minus 2 60. Okay. Minus 2t squared minus 2th minus 6t plus 2t squared plus 2th. T plus 6h minus 2t squared minus 2th. This is all over. 3 minus t, 3 minus t minus h. I think, when did the h at the bottom go away? I never put it. Okay, so I gotta remember to multiply that in at the end. So I want to keep these unfoiled. 6t's cancel out. 2th's cancel out. 2t squareds cancel out. 6h over 3 minus t minus h. 1 over h. 6h over h times 3 minus t times minus t minus h. The h's cancel out. 6 over 3 minus t minus h. When did the 3 go away? In here. Yeah, I don't know when that happened. It's weird. But yeah, this is the answer. Okay, so I'm starting to realize something. Okay, stream's been going on for an hour and a half. I started on not even problem 1. I think I started... No, I finished problem 1. Okay. And there are 36 problems. Alright, so... that's kind of a problem. Because I'm trying to get this all done before the end of August. Okay, so by the 31st of August. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 just in review. No, just 10. So this doesn't count. Let me make this bigger. Okay, so that's 10. Here, no, not this calculator. So there's 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 70 sections I gotta get through. Okay. How many days until August 31st? Or we'll say September 1st. Exactly 90 days. So 70 sections, 90 days. And I've been on functions for, let me check how many streams I've done on this. I won't count the one day where I just watched the video of that professor guy. So 1, 2, 3, this is the 4th day. So that's not gonna work. Can't be spending this long on one section. So let me check. How long is this? So the notes are way shorter. It's way less practice problems. Okay. I'm wondering if functions is just like a really long one, or okay, 11. That's not bad at all. $11. 12. Let's go to somewhere in limit properties. There's a lot of parts to this, but it's not terrible. Somewhere in derivatives, chain rule to 32. Say some days are extra long. Alright. 7. Some of them are really short. Like functions is so long. That's like the longest one so far. How many examples are in like your average one? There's still a lot of examples though. You know, I hate to say it, but I might just have to go through the examples and skip the practice problems. You know what, that is what I'll do. So, and with the extra time I have left, maybe I can do more practice problems, I don't know. But I'm done with practice problems for now. Okay. I'm just gonna do the examples. I'll do examples and watch Professor Leonard. So then I could really get through one a day with some extra time. Because the rate it's going now, like, I know that not all of them are super long. Like, this is 3 examples with 7 problems. But like, come on, some of them are really long. And even then, they have parts to them too. I'm sure these get really long, so. Gotta be efficient. For real, for real. So yeah, let's move on to inverse functions then. So in the last example from the previous section, we looked at 2 functions, f of x equals 3x minus 2 and g of x equals x over 3 plus 2 over 3. We saw that f of g of x equals g of f of x equals x. Okay, but that doesn't always happen. And as noted in that section, this means that there's a nice relationship between these 2 functions. Let's see just what that relationship is. Okay, finding the reciprocal or whatever. So I don't even know. Not even the reciprocal. I don't even know what they're doing. Okay. Consider the following evaluations. So f of -1 equals -5. G of -5 equals -1. G of 2 equals 4 over 3. F of 4 over 3 equals 2. Okay. In the first case, we plugged x equal to -1 into f of x and got a value of -5. We then turned around and plugged x equals to -5 into g of x and got a value of -1, the number that we started off with. In the second case, we did something similar. Here we plugged x equals 2 into g of x and got a value of 4 over 3. We turned around and plugged this into f of x and got a value of 2. It's again the same number we started with, or the number that we started with. Note that we really are doing some function composition here. The first case is really g times f of -1 equals g times f of -1 equals g of -5 equals 1. Wait. Okay, I see. And the second case is really written like that. Okay. Note as well that these both agree with the formula for the compositions that we found in the previous section. We get back out of the function evaluation the number that we originally plugged into the composition. So just what is going on here? In some way, we can think of these 2 functions as undoing what the other did to a number. In the first case, we plugged x equals -1 and f of x, and then plug the result from this function evaluation back into g of x, and in some way g of x undid what f of x had done to x equals negative 1, and gave us back the original x that we started with. Yes. Function pairs that exhibit this behavior are called inverse functions. Before formally defining inverse functions, the notation that we're going to use for them, we need to get a definition out of the way. A function is called one-to-one if no two values of x produce the same y. I remember that from the Professor Leonard video. Mathematically, this is the same as saying f of x of 1 cannot equal f of x of 2. Whenever x of 1 equals x of 2, it does not equal x of 2. So a function is one-to-one whenever we plug different values into the function, we get different function values. Sometimes it's easier to understand the definition if we see a function that isn't one-to-one. Let's take a look at a function that isn't one-to-one. Function f of x of 2, or the raised to the power of 2 squared, what am I saying? It's not one-to-one because both f of negative 2 equals 4 and f of 2 equals 4. In other words, there are two different values of x that produce the same value of y. Note that if we turn, I better expand this actually. Note that if we can turn f of x equals x squared into a one-on-one function, if we restrict ourselves, note that we can turn f of x equals x squared into a one-on-one function if we restrict ourselves to 0 is less than or equal to x is less than infinity. This can sometimes be done with functions. Showing that a function is one-to-one is often tedious and or difficult. For the most part, we're going to assume that the functions we're going to be dealing with in this course are either one-to-one, or we have restricted the domain of the function to get it to be a one-on-one function. Now let's formally define what inverse functions are. Given two one-to-one functions, f of x and g of x, if f times g of x equals x, and g times f of x equals x. Okay. Then we say that f of x and g of x are inverses of each other. More specifically, we will say that g of x is the inverse of f of x and denote it by g of x equals f to the power of negative 1 x. That's how you write inverse, I guess. Likewise, we could also say that f of x is the inverse of g of x and denote it by f of x equals g of negative 1 x to the power of negative 1. The notation that we use really depends on the problem. In most cases, either is acceptable. For the two functions that we started off this section with, we could write either of the following two sets of notation. F of x equals 3x minus 2, and this shows all the ways you can write it. All the ways you can write it, so. Now be careful with the notation for inverses. The negative 1 is not an exponent. Oh, despite the fact that it sure does look like one, it does. When dealing with inverse functions, we've got to remember that. This does not equal this. Okay. This is one of the more common mistakes that students make when first studying inverse functions. The process for finding the inverse of a function is fairly simple, although there are a couple steps that can on occasion be somewhat messy. Here's the process. Finding the inverse of a function. How many examples are there? 3? That's good. Now I'm afraid it's not gonna take long enough. Should I do odds or evens? No, I'll get this done first. I'll do the examples first, see how long this takes. So, given the function f of x, we want to find the inverse function. First, replace f of x with y. This is done to make the rest of the process easier. Replace every x with a y and replace every y with an x. Solve the equation from step 2 for y. This is the step where mistakes are most often made, so be careful with this step. Replace y with f of negative 1 of x. In other words, we've managed to find the inverse at this point. Verify your work by checking that. F times f to the power of negative 1 times x equals x. And the opposite are both true. This work can sometimes be messy, making it easy to make mistakes, so again, be careful. That's the process. Most of the steps are not all that bad, but as mentioned in the process, there are a couple of steps that we really need to be careful with, since it is easy to make mistakes in those steps. In the verification step, we technically really do need to check that both that equals x and that equals x are true. For all of the functions that we are going to be looking at in this course, if one is true, then the other will also be true. However, there are functions that are beyond the scope of this course, however, for which it's possible for only one of these to be true. This is brought up because in all of the problems here, we will be just checking one of them. We just need to always remember that technically we should check both. Let's work on some examples. Alright. So, section 1.2. Example 1. Given f of x equals 3x minus 2. Find f negative 1 of x. Okay, so let me see if I can remember the steps. Y equals 3x minus 2, x equals 3y minus 2, x plus 2 equals 3y by 3, y equals x over 3 plus 2 over 3, f of negative 1 equals x over 3 plus 2 over 3. And then verify. So, okay, the original so f of inverse of x. Wait. So another. This is a weird way of writing this. Let's see. 3x minus 2 times x over 3 plus 2 over 3. It should equal x. I think I'm doing this right. 3x squared over 3 plus 6x over 3 minus 2x over 3 minus 4 over 3. This is all over 3. So 3x squared plus 6x minus 2x minus 4x minus 4 over 3 I'm just gonna look at the example for how to verify this. Now to verify, wait, did I get it right first of all? Okay, it's right. To verify f of inverse of x, so you have your normal function, which is 3x minus 2. 3, plug that in, minus, okay. If it was f of g of x, I would have understood it better. It's weird whenever there's inverse. Okay. So the original 3x over 3 plus 2 over 3 minus 2. 3x over 3 plus 6 over 3 minus 2 equals x. X plus 2 minus 2 equals x. X equals x. And then do it the opposite way. So 3x minus 2 over 3 plus 2 over 3 3x over 3 minus 2 over 3 plus 2 over 3 equals x. X equals x. Okay. So both those are right. And that's it. So. Example 2. Given g of x equals square root of x minus 3, find g of negative 1 of x. Okay, so y equals square root of x minus 3, x equals square root of y minus 3, x squared equals y minus 3. Y equals 3 x squared plus 3. That should be the inverse, so g of negative 1 equals g of negative 1 of x equals x squared plus 3. Check them. So g of negative 1 of x equals square root of x squared plus 3 minus 3 square root of equals x. X squared equals x, which it does, so. X equals x. And then, the other way around, g of negative 1 of g of x equals x minus 3, square root of x minus 3 squared plus 3. So that's x minus 3 plus 3 equals x. X equals x. Check. Next example can be a little messy, so be careful with the work here. Alright, this is gonna be my last one of the day then. I think skipping practice problems shouldn't be too bad, because actually, yeah, it's actually good, because then I'll be able to watch all the Professor Leonard videos. I do want to get a little bit of both in. So, I need more room. Then I just made this page. Doing too much math. Example 3. Given h of x equals x plus 4 over 2x plus, no, minus 5. Find inverse of x. Okay. So y equals x plus h over 2 x minus 5. X equals y plus h over 2y minus 5. So we're going to multiply 2y minus 5 over, cancel these out, 2y minus 5x equals y plus h. Subtract the y over, so 2y minus 5 x. No. It's a little annoying. I don't see what else we can do but multiply this over then. Divided by x. 2y minus 5 equals y plus h over x. And then say like y plus h over 1 times 1 over x. 2y minus 5. That's basically the same thing we had before. Man, this is an annoying one. Very annoying. I just realized I had Paul's on my math notes up the whole time. Yes. Okay. Man, like what? I'm actually, how am I stuck on this? It looks so easy, but it's not. Do I look? Can I get one step at a time? No. Okay, let me scroll down slow. The first couple of steps here are pretty much the same as the previous example, so here they are. Okay, now be careful with the solution step. This kind of problem, it's very easy to make a mistake here. Whoa, okay. So he 2y minus 5 on this side. Y minus 5 x equals y plus h. I don't know what to do from there. 2xy. Oh, oh, okay. He just foiled this. So 2y. How did I not think of that? That was like so obvious. Okay, let's see if I can get it now. Factor out an x. Wait, no, because that's undoing what I just did. Okay. Oh, there's still an x there. The x is so annoying. Like, get out of here, dude. Okay, well, I can at least move the 5x over and the y over here. So 2yx. Oh, no, this is good, Okay. Minus y equals 5x plus h. Okay. So then I factor out a y, which is what I wanted to do the whole time. So y of 2x minus 1 plus 5x plus h divided by 2x minus 1. Y equals 5x plus h, or 2x minus 1. And I think that's it. Let's see. Wait, what? Okay, wait. One step at a time. So 2x... Okay, I have 2yx, he has 2xy. Doesn't really matter, but 2xy minus y equals 2x minus y equals 4. Wait, where'd I get an h? Wait, where? Are you serious? Wait, I'm so confused. Where does this h come from? This is a 4 the whole time. Are you kidding? Dude, I've been doing this all day. It's so annoying. I'm just putting in random stuff. I'm gonna delete all this. Okay. X equals y plus 4 over 2x minus 5 times 2x minus 5 times 2x minus 5. 2x minus 5x equals y plus 4. Whoa. 2x. Is that really? Oh, there should be a y, that's why I was confused. Wait a minute. Now I'm solving. Dude. What is even. No, this shouldn't be a y. This should be. Okay, good thing it's my last problem. Okay. 2y minus 5. Cancel. 2y minus 5. 2y minus 5x equals y plus 4. 2y xy minus 5x equals y plus 4. 2xy minus y equals 4 plus 5x. Y, factor out of y, 2x minus 1 equals 4 plus 5x, divided by 2x minus 1, divided by 2x minus 1, y equals 4 plus 5x over 2x minus 1. Okay, that's right. So then I set the inverse, h of negative 1. Inverse of h, 4x plus hx equals 2x minus 1. Yeah, okay, let me try and check it myself. So h of negative 1, 4x plus 5x over 2x minus 1 plus 4, that's a big one, 2, 4x plus 5x plus over 2x minus 1, minus 5. Okay, 4x plus 5x over 2x minus 1. 4 times 2x minus 1 over 2x minus 1. It's a plus. That's for the top. 8x plus 10x over 2x minus 1 minus 5 2x minus 1 over 2x minus 1. So 4x plus 5x plus 8x minus 4 over 2x minus 1 over 18x minus 10x plus 5 over 2x minus 1. Combine the terms, 9x, 17x minus 4 over 2x minus 1 over 8x plus 5 over 2x minus 1. 2x minus 1 times 17x minus 4 over 2x minus 1 times 8x plus 5. Cancel out the 2x minus 1s. 17x minus 4 over 8x plus 5, I think. Wait, it's gotta equal x, doesn't it? This is not equal x. Okay. Yeah, this is crazy. Okay. So let me see if I can find a step that I was on. Okay, so there's no 17, so that's not right. Is there an 18 ever? No. I can't even read my work. Where do I even start looking? Okay, wait, here. This thing right here, step. Okay, that's the same as this on, yeah, okay. So then after that, four plus 5x plus 2x minus 1. The bottom seems wrong. Yeah, like the numerator here is right. Besides, I just won't FOIL this. Okay, I'll get rid of all this. 2x minus 1 over 2x minus 1. 4x plus 5x over 2x minus 1 plus 4 2 4x plus 5x 2x minus 1 minus 5. Let's move these closer. Okay. So these cancel out. This becomes 4x plus 5x plus 4. Wait. No, I don't think. Times 2x minus 1. Okay, 4 times. Yeah, 4 times 2x minus 1. They just don't FOIL it in. Okay. Then what do you do with the 2 at the bottom? Okay, they FOIL that in. 4x minus 2. Then what do they do with the rest? Does it go to both? Like, yeah, I think it goes to both. So this cancels out. Times 4x plus 5x minus 5. Wait, what? Or wait, okay. Chill out. So 2 times 2x minus 1 times 4x plus 5x minus 2x plus 2x minus 1. Wait, the x is gone for what? Wait, there was never an x. When did that x come in? Was it here the whole time? Dude. Like, why? Why does this always happen? There's never an x. Okay. Well, nice. I have like dyslexia or something. So that's just 4 plus 5x times 2. Now why doesn't, what? Huh? Okay, because this is one term. Okay, I see. Right. So like this already did its job right here, so this can go away. But the 2 stays. Two times 4 plus 5x minus 5 times 2x minus 1. And on top is 4 plus 5x plus 4 times 2x minus 1. Okay. Let's see if I can do the rest by myself. I'm not checking it the other way either, because like this is too long. So 9x plus 8x minus 4 over 8 plus 10x minus 10x plus 5, 17x minus 4 over, I shouldn't have a 17. I wonder where I got that. I'll check in a second. 13. Yeah, it's 13x over 13, which is, well, 17 minus 4 is 13, so where did I mess up? Oh, it's the x, probably. I shouldn't have had an x somewhere. Yeah, it should be a 4. So stupid. Wait. Oh, this is all messed up now. 4 plus 5x plus 8x minus 4. Okay, wait. 4 plus 5x plus 8x minus 4. 4's cancel out. Just 13x is left over 8 plus 10x minus 10x plus 5. The 10x's cancel out. 13x over 13, finally. X equals x. Check. Okay. And this last part, there's one final topic we need to address quickly before we leave this section. There's an interesting relationship between the graph of a function and the graph of its inverse. Here's a graph of a function and inverse from the first 2 examples. So we got this going this way. We got this going the other way. And then we have a point where they intersect. But for this one, see, they're flips, like across this In both cases, we can see that the graph of the inverse is a reflection of the actual function about the line y equals x. This will always be the case with the graphs of a function and its inverse. Cool. So I'll write down what I gotta do tomorrow, which is trig functions. See what that looks like. So just 4 parts, 1 example, seems like. Yeah, I could. Well, no, I won't do odds. I won't do the practice problems. I'll just watch the videos. Alright, that's it for now, though.